For people who have just joined, my name is Aron Brand. I'm CTO of CTERA. So thank you for joining today. And now I'd like to talk about how CTERA is thinking about the transition from storage to enterprise intelligence. So CTERA has started from the storage space. We've seen our customers optimizing their storage footprint, reducing costs, providing access to their data from any location. But over the time, we have learned that organizations, after they consolidate their data estate and create this unified data layer, they really want to unlock the value of their data for AI, for analytics, or other kinds of processing. And this is what we call enterprise intelligence, providing better decisions, better decision making, and better ability to extract the value from this data estate. And enterprise GenAI is really big business. According to Morgan Stanley, they predict that by 2028, which is not so far in the future, it will be about $401 billion market per year. And that's about 22%. So that's almost a quarter of the total software spend. So that's an amazing shift. So why aren't we seeing enterprises doing this yet, right? It seems like it, right? They're doing it, but why aren't we seeing it in production?
That $401 billion represents a net loss of $400 million?
400 billion.
Billion, yes.
So that's the point. And this is something that was released just last month by MIT research, and they found, as part of a survey of hundreds of enterprise companies, that 95% of GenAI pilots fail. Okay, so that's right. Only 1 in 20 of these actually produces any ROI right now. So so why is that? And so we've been talking to many customers. Our customers are in particularly very large in regulated industries, military, federal, healthcare. And we're asking them, why are your GenAI pilots failing? And what we recognize is that there's a perception about using GenAI on your data, which is, we'll just point all these AI tools into all our data, right? And we vectorize everything. We add a RAG layer. We plug in the smartest model that we have, right? The GPT-5. And then we sit back and everything works like magic. And unfortunately, AI, it feels like magic. And every day I'm amazed by the capabilities of the new models and tools that are created, but they're not magic. And the reality is a bit more like this, right? When you dump all your data as it is into these GenAI models, all you get is more convincing nonsense, right? And the stronger the GenAI model is, it's more convincing, but it's not more true. And why is that? Because organizations don't know what they have. They have no data from decades old, and it's if you provide the GenAI, you ask a question such as, what does the regulation say about this action, right? And then it pulls some chunks of documents from different years, and you get wrong answers very confidently. And then what happens is, that the person who is really an expert on this field sends a reply based on that, and then it becomes the truth because he's the authority, right? So it becomes an authority because the person in authority trusted this incorrect answer. So that's a really big problem. And actually, I like to say that bad data is worse than no data, right? It leads you to into the wrong direction. So the next frontier, and what really is required in order to make enterprise GenAI a success, is not more data. It's quality data. Now, and we analyzed this, and we found that there are 3 main quality killers for data. The first is that the data is messy. The data is messy. It means that you have irrelevant data, outdated information, intermixed with good information, so different levels of quality. And in order to solve this problem, what you need to do is to curate your data, to classify the data, that you can use GenAI or AI tools to do this classification, and to enrich, to do metadata enrichment. We mentioned that in previous parts of this discussion, to enrich your files with additional metadata that allows these AI pipelines or RAG pipelines to pull in the correct information and the highest quality information needed for any specific task. The second problem is the problem of silos. And by silos, I don't only mean that the data is split into different systems, right? It could be split into, right? You could have some of your data in SharePoint, some of your data in Confluence, some of your data in the global file system. But it's also, so it's dispersed across geographies, right? You can have different data stored, right, in the US, different data stored in Europe. There might be data patriation or rules that require you to store certain data in certain places, or just due to historical reasons. And the data is also not stored in a unified format that allows GenAI. It's not ready for GenAI, right? Because if you have a video or you have a PDF that's scanned, or a PDF that's or a Word file, okay, you really need to bring all these things into a unified place and format.
Vectorization does the unification.
The vectorization needs to be done after the unification, right? Because a vector database or an embedding model is not able to look at a binary PDF file, right? It's just you have to convert this to something that is either textual, or you can use, if you have a multimodal embedding model, you can feed in images, and then it will be able to answer different kinds of questions, right? But so you really have to convert to some kind of a format that the embedding model will understand. And finally, and this is probably the worst quality killer, or the biggest killer of POCs, is compliance and security, right? Because the compliance problems, especially if you're a regulated industry, are enormous. I mean, the problem that will happen for a company if, for some reason, their GenAI assistant will start spitting out some PII or health information or information about payroll, it could be disaster. It could be a disaster for compliance. So they could get fined, and it would be very embarrassing. And it's very hard, right, to predict what will happen. You have this black box. People ask questions. They try to trick it, and you have no idea what will speak back unless you know what you fed into it. So it's very crucial to have guardrails around the data that is ingested into the system, so at the ingestion level and at the output level, right? So to protect the system, to look at the output, to look at all the different steps of the pipeline, and to enforce guardrails about what is allowed within our organization. And finally, you must preserve the access controls of the original files, right? Because if you assume that users have access, there are many systems that allow you today to make sure that the access controls are correct, right? And almost any big regulated industry has these tools like Varonis and other data management tools that allow you to make sure that the ACLs of the files are correct based on what's in the files. So we want to preserve this when we add the GenAI assistant, so it will enforce the same permissions that files have today, and not lose them as part of copying your data to another unmanaged system. So these are
We've just been kind of discussing this in the back channel. All of these things still don't guarantee that you will get the right answer.
Absolutely, there's no guarantee of a right answer, but these are the basic requirements before you could even start, right? So there are a lot of steps after that, and this is exactly, I mean, nothing will allow to guarantee correct answers. But I'll show in a moment what we're doing, and that is to provide the ability for the users to verify the answer.
Well, it's what would require getting the right answers that artificial intelligence actually had some intelligence, which it does not.
Yeah, that's a philosophical question, whether artificial intelligence has intelligence and and on a question, I ask your question, do people have intelligence? That's also a
It's
good
not
question.
philosophical. It's artificial intelligence today is just echoing back garbage that it was given.
And so are we, right? Aren't we?
Touche, Andy. Touche. You could have said that. You could have said that. Well done, sir.
Yeah, I could talk to you,
Okay.
hours about that.
I'm not going to derail your presentation.
Too late.
The AI, yeah, you're absolutely right. It's very if you give it bad data, which is bad answers, and we are trying to do our best to allow the organization to curate the best data, best quality data, and to allow the users to verify. We're not in the state today where we can allow the AI to trust it entirely, and I don't know if we ever will. So the steps of curating data for GenAI involves first collecting them from the different storage silos. So it could be from NFS, SMB, S3, SharePoint, OneDrive, whatever you have. And the ingestion should be timely, right? You don't want to have this collection happen on a monthly basis or on a yearly basis because you really want to get relevant answers, right? You want to ask, what are my competitors doing on this matter? And if they announced something yesterday, you wanted to know that. The second, and then you have the format unification that we mentioned, where you have to bring all these different file types. Some could be scanned PDF, some can be video, some can be audio, meeting, transcripts, Word files, and build some kind of a unified format that is more suitable for GenAI. Enrichment of the metadata. So you can take these documents and enrich. If you have a repository of contract, you could say, what is the signing date? Who signed it? Who's the customer? Okay? So you add this semi-structured layer over the unstructured data that helps the RAG engine to pull in the right document. And then you do filtering of the data. So you would instruct the system to drop information based on certain rules. So you would say, okay, if it contains personal health information, drop it. Drop the file, or redact this specific part before you provide it, insert it into the index. And only after you do all these, you can do the vectorization and index.
So where does CTERA play in this flow?
That's a good question. I'll show you.
I have a question too.
Yeah.
But before we get, can you stay on that slide real quick?
Yeah, of course.
So the timely ingestion and format unification. So what happens, like, let's take your example of a competitor announcing something. What happens if that's on a longer document, that's a PowerPoint or a doc? It gets pulled out of that document, but what if I make an update to the document? Do you guys update the format unified?
Yeah.
File?
Yeah. So I'll show it in a minute, but what our data intelligence system essentially does is to connect to all these data sources. The main one would be our global file system, and it works using our notification bus. It wakes up with it wherever the file is modified, and then it runs the pipeline again and replaces the chunks of the file with the new ones. So yeah, that's exactly what it does. And so you can be sure that you have the latest version. And typically this can take seconds, right? I can drop a file into the system. Within seconds, it's already available for question answering.
So that means I'm keeping two versions of the file. I'm keeping the file that's human readable, that's in my format that I want it, as well as this reformatted for. Yeah,
that's a semantic layer. So the system builds this semantic version of all your documents, right? And it stores a textual version. It stores some descriptors that contain some metadata that were extracted from the file. And this is what actually is used by the GenAI, and not the original source documents. You can even move them to archive, right? You can move them to Glacier. You don't have to pull them in order to answer the question.
Okay, thank you.
So our vision of data intelligence is to provide us a platform that allows you to move all the way from curating your data, right? So creating these high quality data sets, carving them out of your data, and tagging them and enforcing the permissions and the guardrails, creating guardrails over what is ingested, a retrieval layer that allows you to deliver precise context that you can provide to your GenAI tools. And then on top of all that, our vision is what we call virtual employees. Virtual employees are like subject matter experts created by the users themselves. Okay, so the system is designed in such a way that a lawyer or a secretary or anyone within the organization is able to automate the most annoying parts of their work, or the parts where an agent would help them do their work faster and more efficiently. And they can encode their knowledge in a very simple way into virtual employees that we call experts. And finally, we build the system to respect existing ACLs or other permissions from the source data. So users will get only answers based on something that they're allowed to access anyway. And we built it in a way that it provides trustworthy answers that you can verify and validate because they're grounded, and it shows you the source of every answer. And the vision is to extend your workforce with a virtual team of assistants that every user can add for themselves. And so it's not replacing users, it's just making their job more efficient and more enjoyable. And this platform is powered by MCP. MCP is the underpinning of everything that we do here. So it has both an MCP server, so you don't have to use our user interface in order to interact with these experts. You don't have to use our chat interface. We provide one in case you want a turnkey solution, but in fact, we believe that most of the usage would be through MCP, allowing you to access this wherever your employees are present, right? Wherever they do their work. So if they work in Teams, in Copilot, in ChatGPT, or anywhere else, their virtual assistants are there to help them. And the other side of this is the MCP client, because the system also allows invoking external tools, right? We don't want the system to be a closed system. We want to be open, and MCP client is the best way to do it. So you can tie in any external tools using that support the MCP protocol. It could be you can have the system send an email, create a document in Confluence, or whatever system that you have, either using one of the thousands of MCP servers that are available today, or you can develop your own. So it's built to be an open system. And now I'd like to show you CTERA Data Intelligence in action. Okay, so I'll be switching back and forth between the administrator interface and the end user interface, and I want you to remember that the end user interface is only an example, and you could do everything through MCP or through other AI tools. You don't have to use ours. So the most important part in CTERA Data Intelligence are the experts. The experts are the virtual employees. And users can define these own experts. So you could see we have 3 experts that are defined here: a paralegal, a news analyst, and a lab assistant. Okay, these are user-defined, and we have this collaboration capabilities. So these are my experts, and I have a shared with me tab that shows experts that were shared with me. Okay, so this is the self-provisioning aspect of our platform, where we don't think that people from IT should create experts for their users, right? They should do their own. And here you see a Navy maintenance expert is shared with me. And now LLMs, the system is built to support any LLM. So you could use Claude, DeepSeek, OpenAI, whatever you want. It's built in an open platform, and even private LLMs like Llama. It's really not dependent on any specific LLM. It's built in a generic way. And as you can see here, each of these experts has some documents or some data set that's associated with it. The data sets can be from different sources. So you can have CTERA portal or global file system as a data source, or you can have a website, or you can have Confluence. And we're working to add more and more data sources to this system as connectors. So it's built to pull in your data from wherever your data is. And then after that, you have data sets. So data sets are curated high quality subsets of data selected from your data sources. As you can see here, I have legal documents, medical documents, and these are also self-curated by your employees. Now let's go into the chat interface, and let's look at the paralegal expert. So now ask it, do we have petroleum contracts? Okay, so now it's using MCP to run a CTERA search. And here it provides me three contracts. And on the right, I can see the text of the original file, and I can verify this response is correct. Now I'd say perform comprehensive research, and I wanted to compare three contracts. As you can see, it's running quite a few tools. It's doing a deep research and providing me a table comparing three contracts. Now this will be a very time-consuming job for a person, right? I have to read the contract, compare them side by side, and it's done it in seconds. Now let's look at a news analyst expert. This one is an expert I built based on Gemini Pro. It's a very, very powerful model. And the role of this expert is to use MCP in order to pull in an RSS feed, read the documents referenced by this news source, and create an analysis that is suitable for me and tailored to me since the system knows my role and it knows who I am, it's integrated with Active Directory, it knows my role description and my groups, it's able to actually provide an analysis that is tailored to me, right? So here's an example for the MCP servers that I connected, and this expert is using the URL fetcher expert in order to bring in the RSS feed and then bring in the files that are, or the documents that are referenced by this news source. Okay, and as you can see here, the user provides plain text instructions, how they want this expert to operate, what kind of answer it needs to keep, what is its tone, what it wants to avoid, and it doesn't require any programming. So let's try this. So I just paste in an RSS feed from Berkeley, the Berkeley AI blog. I press it in, and let's see what happens. Okay, so it says, I will produce an analysis of this blog tuned to your interests as CTO. You see, it's tailored for me. And now it's calling the MCP tool. It's fetching the RSS feed, and then it's fetching all the articles that are mentioned within this feed. And again, I didn't develop a single line of code in order to do this, and it provides me this report tailored for Aron Brand CTO based on this. So it could save me a huge amount of time to understand what is relevant for me within this news source. Right? So and all of us, how much content we have to read every day in order to stay updated. Think about getting this kind of report every day that summarizes everything while knowing your interests. So I think it's amazing. Now let's jump into a medical use case. So the system is built for very sensitive.
Excuse me, Aaron, before you continue. All of these agent activities are running where?
The data intelligence system incorporates a chat interface, right? Which you can use if you want. Mm-hmm. And in this case, the chat interface has a backend that orchestrates the calling of tools, right? But at the same way, you can also use Microsoft Copilot which already has also the ability to call MCP tools,
Right.
and you could use it from there, right? So it doesn't really matter as long as the front end supports MCP.
No, I understand that. But so you've built a data intelligence solution into the CTERA storage system.
It's so this is an add-on, right? It's an add-on. It's not something that all our customers have right now. You have to buy another part of the product, and it can work with the information that you have in the global file system or other data sources. Okay.
I mean, like this is running on the CTERA processing engine, the storage solution, right?
Yeah.
Okay.
Okay.
So the add-on is the MCP client and MCP server. Is that how you package it? Is that kind of the way it's?
So the MCP server, it contains an MCP server that allows you to invoke these exports from tools that you have, like workflows like NA10 or from Copilot or from any other tool that supports MCP. And it has an MCP client that allows you to deploy tools within this agentic flows. So like fetch a URL, send an email, read my mailbox. You can do all these things, and you're not limited only to operate on this private data estate. You can also it gives the arms and the eyes for this AI model. Now the system also knows how to classify and augment the metadata of the files, and this is what Simon was talking about earlier, where I could say, I want you to extract certain pieces of information from every file in this data set. And I do that by specifying a JSON schema. In this example, I'm showing a medical use case. So there would be examination date, examination type, and so on, the different fields that are extracted. And we use GenAI models in order to take this unstructured document and convert it into this kind of a semi-structured format that's appended to each document. And we can use a combination of this metadata together with the semantic search in order to come up with the best answers for each question. And you can even use this information for analytic use cases. So you could say, how many documents do I have that have examination types set to blood test? Right? So it will give you a numeric answer because it's able to do like an SQL query on this data.
So the answer will be 42.
What? 42.
Yeah.
Still 42.
Yes.
The answer for everything.
Well, this is maybe I missed it, sorry. This is the metadata enhancement definition.
Correct.
So we're in the metadata enhancement phase.
Right.
There's something very human readable about that. Is there a way that you are so the closer you can get to the expert, in this case, a medical data analyst type person, to defining the schema without requiring them to understand schema formatting,
right,
the better off you are, right?
Yeah.
But this doesn't strike me as the medical data analyst interface of choice.
So you're asking about why are we providing a JSON?
Well, sort of. That's the technical question. It's more like, and maybe it's an unfair question. How are you enabling the let's say the stakeholder, the user stakeholder, to influence this without a layer of, without an additional layer of?
Well, if it's a simple classification where you have certain fields, so we have some simple classifiers, so such as the keyword classifier, where all you do is enter a set of keywords and then it will add tags. So this is not the only way to do that classification. You could do it without the LLM. We started with this. What I showed you is the most powerful classifier, and it's conceivable to create a nice user interface about this, right? To edit this. We haven't done it because it's so powerful. It allows, because the JSON schema allows things like lists. It allows you to do things like things that are not one-dimensional. It could be nested. So it's pretty hard to do this with user interface. We might do that in the future to have like a builder, right? But if you're a user and you don't know how to write JSON schema, all you need to do is in ChatGPT, write me a JSON schema for this.
You need to know to ask that, but yeah,
But,
fair enough.
You know,
Okay.
But, yeah, but I agree. It's a usability, good usability enhancement that we're considering doing. So just show you a bit the results of the classification. So I have some medical reports. I click here on this document, and I see here the metadata. And you could see down here, medical document metadata, the name of the doctor, summary of what's in this document, the examination date, and the examination type. So this is so powerful for an enterprise that has no idea what they have in their file system. This is like 10 levels up with what they have today. They could really understand what they have in their data. Now let's see this in action. So find all kidney function tests in our database. Okay, so the system is thinking of it and providing me a list of the tests that I requested and with a summary of the findings. And now create a table of the tests with anomalies. Okay, so it's providing me the result. Please explain each anomaly. And now here the AI is using its own knowledge in order to explain what this means and create a presentation using reveal.js. So now, right now, what it did now, it created code, JavaScript code, create a presentation, within seconds from the data. So yeah, I think that's very, very impressive what the AI is capable of doing today.
So how many HIPAA violations are in that?
Question. Is there a way, so what you've shown us is what I would assume would come up if you've got the data and it's completely raw.
Yeah.
There's a lot of that of what you've just shown us that is really objectionable from a compliance point of view.
And of course.
Address that for me.
Yeah. So first of all, this is not real information, obviously, what I showed you here. And this is not something that will be available in the open. But and now the system has the ability to redact specific fields. So if there's the name of the patient, right? Here, for example, we didn't enable that. This was just made up names. Mm-hmm. But you typically have it anonymized when you as part of the feeding process. We'll just remove the names of the people.
Is that a manual process? Is that something that you can automate? Talk to me about that, because I'm envisioning a healthcare provider that might have hundreds of thousands of these lab reports. And yes, I understand the scientific value of being able to say, okay, give me all of the times that we've run this particular exam or this particular lab in our facility. I want to have some statistical analysis on that. But the flip side of that is that in order to be able to have that data, it has to be anonymized in some fashion. So either somebody's got to scrub it manually, or there's got to be some kind of way that you can assure compliance authorities that your AI bot is not just pulling up all of this HIPAA sensitive material.
Of course.
And the security folks are just basically going apeshit.
Absolutely. Yeah. So I agree. This might not be a very realistic example. What I showed now, it was more to show the power of the system. The system does have the ability to redact PII and anything that looks objectionable. It removes it at the source. And I do expect that things like this will be done on data that is already cleared by the right committees, that is pre-anonymized, and our guardrails will just be another step to add another level of assurance.
So manual then. It's a manual process at this point.
It has this abilities, but the LLMs, I wouldn't say that if they can't be tricked or they can make mistakes. So this kind of a use case would typically run on data that is already pre-anonymized. This is an example for a research use case, and you wouldn't just throw information right from the patient charts directly into this. So I take it as feedback, and you're right that this might be a little bit alarming to people from the industry, and I'll make sure to correct it.
For sure. For sure.
I think it's alarming because I mean just that last line there of like provide a prescription for the first patient, right? The alarming thing for me would be that could be sold into an industry that doesn't understand this is not a source of truth, right? This is just statistical generation of something, and so it could turn into something that we're all afraid of, right?
We're not able to solve the problems, the fundamental problems of AI and our trust for AI, and but we are providing the tools. We're providing the way to deploy the agents, right? So, but it is designed to be used on sensitive data, right? So the system is built, and it's there are many different AI frameworks and SaaS RAG platforms and so on in the market. But we are really try to make it, this is our focus, to connect your private data estate and the sensitive, whatever you don't want your doctors to paste into ChatGPT. Okay, so there will be a lot of permissions around this. There will be a lot of guardrails around this, and it will be used. It has to be used, but in a responsible manner. Absolutely.
Yeah.
I mean, because it is first, and so I think one thing that I'd like to kind of focus in on, because I came down on this particular example because it does have objectionable information in it in the context of the example. But there are use cases where I'm the healthcare provider. I'm providing healthcare to Ms. Smith, and I need to pull up something from Ms. Smith's file, and it's information that I'm searching for that's very patient specific, but it's also something that is appropriate. And so I think one of the takeaways that I'm getting is that before we can even feed this data to an AI or to an LLM, excuse me, or before we can even have an AI bot access this data, we really need to be very careful how we curate the data ahead of time. And I think that that is the thing where we need to focus more time on is how many different ways can we come up with bad outcomes because we haven't carefully curated.
Come back and join us for AI ethics field day.
That's a thorny field.
Yes,
absolutely. I totally understand, right? This and this is really our approach, not to throw all the data into AI, and even worse than that, we're seeing customers are talking to us and they're saying today we have some kind of an AI tool, and the way it works is that our employees take files, they drop them into this other system, and then they can share with each other, and they get responses, and then they have another unmanaged shadow data copy of all these sensitive files in some kind of a SaaS system that nobody knows what's there. So this is really the core here. We believe that we need this system for the more security sensitive part of the business for these but it can provide you real business advantages, right? If you're a legal, let's say that you're a company that provides legal medical advice, right? Advice in a lawsuit, right? You might have 300 or 500 documents related to this lawsuit. Right now, you want to save the cost. I mean, you don't want to have a doctor. That's what they do today. A doctor can work a week. They have to analyze this thing, and then you bill the patient for $20,000, right? Now, what if we can do that on a comparable level within a minute, right? That would be a game changer for healthcare, right? It will make our health insurance cheaper. So we have to find a way to make it secure. That's what we believe in. And it's up to our customers to find what they can do within their regulation, but we will provide them all the tools to do this in a secure fashion. Now, here's an example. You can see here I asked, I created a guardrail that says you're not allowed to provide direct medical advice. You say when I said provide, it answers questions, but then when I say provide a prescription for the first patient, then it says, right, your request violated corporate policy. Okay, so these are the examples of the tools that we provide, and our customers, should do it to the best, to make it as secure as possible while respecting their regulations. Finally, I have one more example, actually two. This example is using the system through Microsoft Copilot. Okay, so I just wanted to show you that I could ask questions through ChatGPT, or sorry, through Microsoft Copilot, and it will use MCP to invoke the system and do the same in-compliant thing that you just complained about. But so you can do it. You're not restricted to do that through our interface. You can do it through wherever your employees are already active and improve their efficiency. And the final thing I wanted to share you is an example for maintenance and engineering use case. So in this case, we have a naval maintenance and engineering officer that's trained on very, very old documents. So what we actually I fed here is some scanned documents from the 1960s about maintaining helicopters and all kinds. This is a very technical and complicated data set, and also the quality is not very good. But we're actually using VLM, or a vision language model, as a state-of-the-art approach for OCR, for question answering on image data. So in this case, I'm pasting a question, a mission debrief, and asking what is the corrective procedure in case we had an over RPM incident on our engine, and it's running the search and providing me the required procedure by looking at these documents. While providing me the citations, I can click on and I can check that this is really the correct procedure. Now, you might have, as a naval officer, you might have documents. You might have a stack of documents that's smell like engine oil up to the ceiling, right? And might take you hours to find the right answer. And here you can find it within seconds. So
you can actually find it within seconds if you actually just scan it and do an OCR of the documents, and then use a general purpose search engine on it.
So it's the OCR this is a pretty much state-of-the-art OCR. So I've never seen any OCR tool as good as what this VLM is able, including understanding charts, tables. It's just amazing. It's much better than anything I've seen before. So yeah, it's a new form of OCR. And now the next part is answering the question rather than looking by the keyword, right? Because there was nothing in my question that was actually a keyword that existed within the document. So I could search for maybe over RPM, and I would find over RPM for this helicopter and for that one and so yes, it can be done using previous technology. But when we actually showed it to customers, they said, "Oh my God! I mean, no OCR is able to handle these documents." Okay, yeah, but of course, the system you can use full text search, and I would say search engines exist for decades, and but the reality is that they are these very technical and complex cases, and the reasoning. Right, the reasoning capabilities of the system don't exist in the search engine. So because it's able to do multiple step questions, right, and do multiple searches within the same query and combine information.
You're somehow implying that there's a reasoning capability in today's AI LLMs, and that is definitely not the case.
Okay, that's again the argument whether we have good reasoning capabilities, and I think that. I'm sure that the AI is not worse than the worst people in that capability.
That's a very, very low bar.
Kind of the point.
Yeah, the proof would be if it's useful, right? If people feel that it's useful and they'll use it, and if the accuracy is good, then it does what it needs to do. But when I say reasoning, what I mean is that the answer is not necessarily within one page of one document. Right? The answer could be, in order to, the system knows that, like the question like I showed of compare these three documents, right? So there's no answer to that in one of the documents. You need to do multiple steps in order to answer this question, and it just does it much faster than a human. But yeah, your skepticism is, that's very understandable, and but I think we're in a very fast evolving field, and even if it's not good enough today, I'm sure that in 2 years, that will be a thing of the past.
Do you actually supply a vector database and embedding solutions and things like that, vectorization, or are you using other tools for that sort of stuff?
Good question. So we, the embedding model, we currently allow you to select the model, like we allow you to select the LLM.
Gemini or Llama, whatever. Whoever wants to do the vectorization.
Yeah, but we actually recommend the open source models that we prefer over the cloud solutions, because one of the concepts here of the system is that we don't want your information to move to the raw information to be moved to the cloud. That's very expensive and very large. So the operation of all the initial operation of indexing and preparing your data, we prefer it to happen on premises with your GPU infrastructure, and actually the embedding is a relatively lightweight part of this.
The vector database is yours, or is it somebody else's?
So we work with open source vector database, and so it's pretty much a standard solution.
Right.
Okay. Anything else?
The interface there that you provide. So what's the licensing or sales model on this? How are you selling it? Are you adding it? What are you doing?
So the system is we market it today as first of all to our existing client base, and when we sell to our existing client base today, we mainly pay by the capacity. They pay by the capacity.
Yeah.
So we have it as an add-on to their system, and it's based on the capacity of their global file system. Now we have other customers that are coming from the AI side of things. So where the problem is not actually related to storage, but it's related to, okay, we have this data set and we want to, and that's very sensitive and private, and we want to have this RAG engine and answer engine. So in those cases, it's a bit complicated, because it's possible that you have a very small capacity, like a terabyte, right? 1 terabyte, and it will be worth a lot business-wise. So these are a bit more complicated. So we have some kind of a minimum price for this solution. We don't really want to go down to 1 terabyte. So there's like a minimum. So that
which you would take under management. You pull that 1 terabyte or 1 petabyte into CTERA, even if the rest of what they're, because this is a green field for you and maybe for them.
They can use they can either move it into our global file system, or they can keep it on their source system, and they'll only use our semantic layer. So
okay. Yeah. So if I get this right, so this is an add-on for existing CTERA customers, because hey, they're going to bring more data in, they're going to pay for that data within CTERA, and this is an add-on to that.
Yes.
That's encouraging more and more uses of more and more data within the CTERA system. That makes sense. But then, if you're coming in from a different angle on it, and you're not putting everything in CTERA, at least not yet, then you're going to pay for that.
Exactly.
Okay. Makes sense.